Welcome everybody. Today we're going to be going through some study guide questions. So hopefully this will be a helpful review for you. We are going to have another synchronous class or together class before you take your unit test, but just wanted to go through some examples, hopefully in a way that will be helpful so you can see some high quality procedures and a quick kind of condensed review of all 5 of the videos before. So I've spent multiple hours watching all the videos. You can get some of the key takeaway points right here. So starting off with 1.1, or the first thing that we did together, we're going to go through 3 different types of questions. So the first of which is solving multi-step equations. So remember, inverse operations is how we're going to start off here. 7x, we're going to get to 35. Before I go on, we define inverse as our opposite operations. So inverse ops, some things to think about. If we see addition, we're going to use subtraction. If we see multiplication, we're going to use division, and the same thing here. Okay, so that is why I had subtraction here. That's why I chose to use addition here. Next, 7 times x, so the opposite of multiplication, as we see up here, again, division. So that is what I'm going to use for that one. And I keep on getting kicked out today, so I'm sorry. So let's go ahead and divide both sides by 7, and we'll get x equals 5. Our next one, again, same steps. The inverse of -8 is +8. So we're left with 3 over 4 times x equals 9. This is a different skill because we are talking about the reciprocal. So if we have fractions, we basically flip them upside down. So here, if we have 3 on top and 4 on the bottom, our reciprocal is going to be 4 over 3. And if we multiply both sides, we distribute it in by 4 over 3. We're going to see we're going to get 12 over 12x on the left. We'll get 36 over 3 on the right. So 12 divided by 12 is just 1, so we have x on the left. We divide these out, we get x equals 12. All right, our last type here, distribution. Gonna bring that in, or we can also divide both sides by 12. It's up to us. I chose to distribute here. You can do whatever you like. So again, if you would prefer to divide and divide, that is another option that you have. But I just wanted to go through this one. So 12x minus 36 equals 108. And then now going through again, inverse operations, the opposite of minus 36 is plus 36. So we're going to have 108 plus 36 on the right side. That's going to give us 144. And don't be ashamed if you got to use a calculator for that. To be honest, I actually just did a double check because I didn't want to make a mistake on my video. So again, bigger numbers, it is actually probably a good idea to do that because everybody makes mistakes. And we're left with, again, x equals 12. All right, so there's 1.1. Any questions on that, feel free to reach out. Got some clear operations for you there. Going on to 1.2, absolute value, some fun ones here. So the absolute value is just our distance from 0, and that is expressed as a positive, always. So always, always, always positive. I can't spell from today. So in this case, -18, if we're looking at our distance from 0, is going to be 18 jumps away, so just positive 18. Next, going through and solving the absolute value of -4, just like above, same idea, just positive 4, multiply that by 9 to get 36. And that's our final answer, because again, we know the absolute value of -4, we know that it's just positive 4, so we can go ahead and solve. I guess a little bit more tricky now, but we're ready for it. So subtract 4 on both sides. Because we always want to get that variable as isolated as possible before we do anything else. And once we get here, we're going into our plus and minus step. I've seen a couple different ways to do this. I've actually done this a couple different ways. So I just want to name that. If you want to distribute the plus and the minus on the left, you are allowed to do that. If you want to distribute it on the right, you are allowed to do that. So make either side totally negative. This way it looks a little bit easier if I put my negative on the right side, so that's why I'm going to do it that way. Sometimes there's only one term on the left and multiple terms on the right, so whichever side is easier for you is okay, as long as the negative goes to every number that is there. So 2x here equals 17, divide both sides by 2, and our positive solution is x equals 17 over 2. So that's for here. I know that I don't have enough room, so I'm actually going to bring this one up over here. Again, I care about my professional work products. So I'm caring about those quality and procedure points. That's why I'm making sure there's enough space here to do this. So 2x here on the left, add these together again, negative, so be careful. -5, divide both sides by 2, and x equals -5/2. So those are our two solutions. So again, before you touch this absolute value here, make sure you get that constant over to the other side. All right, next up for skill number 1.3, interval notation. What this means is we have our start and our end. We use parentheses if it's not equal to. We use brackets if it is equal to. So here, I know I'm going to use parentheses because I don't see an or equal to. X is less than 7. So if I draw this out on a number line, less than is to the left. So I know that my end point is 7. My starting point goes on forever to the left, so -infinity. Again, I already determined I'm going to use parentheses. So that's what I'm looking for there. All right. Our interval notation, we have a union here, so very, very careful. I try to trick you on the second one, so be careful here because I did have the opposite signs. My advice to you is actually to break this out into two different questions. So to have 2 is less than x, and to have x is less than 19. And this is an and one. So again, I'm going to draw out both of these. So you can also read this as x is greater than 2. And then x is less than 19. If I'm looking at this on a number line, I see where I start. Because it's an and, I also see where I end. So I go from 2 to 19. Again, I don't see any equal signs here, so I'm going to use my parentheses. So there's my interval. The final one, or notation. So again, that is one of the two has to be true, not both. So you might see a union here. So again, I'm going to graph both of these first. Less than -4. Greater than 9, seeing two different intervals. So I have to define each interval separately because, again, they do not come together. There is no common or shared answers for these. So two different intervals. So start off at -infinity. And I just wrote 8. I was thinking, write a sideways 8, Mr. Rudin, and I just literally wrote an 8. -infinity up to -4, and then union with 9 up to +infinity. All right, so hopefully that helps us. For intervals, we will be using these for solving some of these inequalities next, which is our skill for 1.4. So with these, my advice to you, solve each independently first before you do anything else. So an or inequality means one, not both of these need to be true. So I'm going to solve this one and graph it, solve the second one and graph it, and see where that leads me. M is less than -6. Okay, going to the left here. Again, a reciprocal or an inverse operation for this one, I'm going to multiply by 8/1 or 8 on both sides. And that's going to leave me with 8/8m or just m, and is greater than 8. So if I continue the same number line here, this looks very similar to the one that we just did the interval for. So -infinity to -6 is our interval on the left, union with 8 to +infinity. The big difference with and intervals is these, generally speaking, have to come together. For both to be true, they do have to share some answers. If they don't share any answers, then it's not true. It doesn't satisfy both conditions. But again, the same steps going through and solving, just our interval will look a little bit different. So a second example here, x is greater than or equal to 1. A very similar example again, use the inverse or operation or our reciprocal here of 7/1 to 1/7. X is less than or equal to 7, and hopefully we might just be able to see it by looking at it, but we start off at 1 and go to the right, and it is shaded in here because we do have our or equal to, and on this one we start off at 7 and go to the left because it's less than, so another or equal to. So we actually do see our start and our end. We're going to use some brackets here, so a nice clean and interval. All right, last skill, probably the hardest one in the unit, excuse me. The way that I think about these absolute value inequalities is if it's greater than the absolute value, generally speaking, that's going to be an or it's going to be going away from. So your graph for this one, before even looking at it, I'm going to say it's going to look something like two different directions. If it's a less than, that's going to be an and or coming together. So expect that for less than inequalities, expect this one for greater than ones. So again, when we see absolute value and it's greater than, we're going to have two different intervals. And again, we always use our positive and our negative So we're going to have x is greater than, and because we changed the 2 to -2, that means we flip our sign, because in order to do that, we needed to multiply by a negative. So x is greater than 2. I'm going to graph that up top. And then x is, and I'll draw it on the same number line here to be more consistent, x is less than -2, so going to the side, so a union interval. Again, we've seen a few of these now in this video already. And again, start and end points, keeping consistent, making sure I'm carefully using my intervals. So you're going to see that there. And I'll just do one more example for a less than one. So on these ones, again, still positive and negative constants. The only difference with this one is it's an and. So it's going to look like this. So instead of the or, where we're kind of flipping everything around, here technically this actually is flipped if you were to rewrite it on the right side, because x is greater than -2. You're going to see x is less than -2. So we go through, we want to solve these out individually, but it turns out there's nothing really to solve. It's already done for us here. Just time to do some graphing. So x is greater than or equal to -2, shaded because it's equal to, and x is less than 2, again shaded because it's equal to. So a start and end point we see clearly. -2 to +2 is our interval there. Same steps when they get bigger, so same basic steps when they get bigger. Just something there to look out for and to see. So thanks for watching, everybody. Hopefully this review helps. As always, questions, feel free to bring them up. Be ready to ask them during our review session when we go over this video in class. And I will see you very soon.